Just to wrap up this step, I want to take a final look at a program that once again opens a text file and once again processes it in a certain way. This time it reads the lines one by one and it searches for strings in those lines. Now you find this in 03_file search str. This time the find strings function down here is the one that opens the file. If the file is found, then it counts through the lines one by one, much as I did in the line counting program that I looked at just now. But in addition to just counting the lines, it also calls the search string function. And the search string function should look familiar. It's one that I developed for an earlier program. And in that case, I searched for a substring in the string that was entered at the command prompt by the user. Well, this time I'm using the same function, but this time the lines are passed to this function, and those lines are the lines that are read from the text file, and they try to work out how many lines in a specific text file contain the substring that I specify. And when I run the program down here, I'm searching for these substrings, then, my, and Snodgrass. And the text file I'm searching in is sonnet.txt. Once again, I've had to make sure that this file is in the same directory that the program runs in, with the IDE that I'm using, CodeLight, by default, that is in the debug directory beneath the source code directory for the project. And so if you want to try it with other text files, make sure that you copy the text file into that directory. The text file itself is here. This is again the same sonnet. And so if you want to check where the words that I'm searching for exist, then just open up the text file and run the program to compare the results. I'm going to compare it now. Build and run project. And these are the results. It says that the word then was found on 2 lines, my was found in no less than 6 lines, and not surprisingly, Snodgrass was found in 0 lines. So I'll leave you to look through the code at your leisure. All the code is of course supplied in the source code archive. And if you want to experiment, you can of course go on and try adding your own functions. For example, if you read the text file 1 character at a time instead of 1 line at a time, you could count the characters as well as the lines, or you could change uppercase characters to lowercase, or do some other sort of processing on those characters. For example, you could encrypt the text, and remember, that's something that I looked at back in step 6. So if you want to try that, you could write an encryption program which reads in one text file and writes out a different text file in encrypted form so that nobody can see what it contains. And of course, you could then write a different program to read the encrypted text back and turn it back into human readable unencrypted text. Okay, so that's enough about text files. But what happens if you have different sorts of files that contain data such as CD records? For example, I've already shown how to create a simple array of CD records that represent a CD collection. What if I want to save those records into a CD database on disk? Well, a text file is not ideal for that, but a binary file is, and I'll explain how to do that in the next step.